Bismillahirrahmanirrahim. My name is Rashid and I'm a student of Mechatronics Engineering and I'm studying at University Islamabad. And in this semester, I have been studying microcontroller and embedded system as my subject, and I have performed various tasks and some projects. And this is the last project of this course, I hope. And as we were told by our instructor, in this project we had to explain the working of Zumo Maze solver, that is a sample project in Proteus, and while explaining it we also had to add some new functions to it, in which we are interfacing SD card which will save all the values that are displayed in the LCD here, which is also added by us. So let's start explaining it. So in this project we are using sensors, and using the values from sensors we have created a program, and it will run on the line, but it will solve a maze which is a complete, meaning that if it has no end the robot will keep running in it unless there is an end to it. And for that we were provided arena by our professor. The arena is basically the path on which the robot will move. Basically it is the maze. So let's run it. Unluckily I am facing some errors and it has happened here as well. Let's run it again. I'm using Proteus 8.10 and there were no errors in previous versions. I don't know why are there some errors in this version, or is there something wrong with my PC. Let's try to run it one more time. And I hope it will work this time. I have added all the files, but let me add them again if that's the problem. I can explain it as well. You have to add the MMC file for your SD card. Unless you add it, it won't work, which I have already added, but let me add it again. And you may want to add an arena if you want to, but there's also an arena in it along with the sample project. So let's hope it works this time. I think it's working because it is taking some time. So basically in the SD card you will add the MMC file, and in your robot you are going to add the arena. Arena is the path which it will follow, and once the simulation, let me try it one more time. I have no idea why it's not working. It was working pretty well earlier. Bismillahirrahmanirrahim. So in this project, this is the source code, but let's run it first. And it's working this time. I have no idea why it was there error in the previous simulation. Though I am using a previous version of it, I had some changes in that program, but this is much simpler, but it is containing all requirements. So first of all, this is our robot and this is the SD card. You may need to click on it. Unless the SD card is inserted, it won't work. And as you click on this button, this is the Zumo button, and here is the speaker. You can hear the sound. It will run left and right. Let me show you once again. When you click on the button after the initialization, it once moves left and right. When you click this button, it moves left and right for the calibration. Let's see why it does that from our code. I think I haven't run it till destination, but we will do that later. First, let's check our code. So these are some files which are added in it, which serve different functions. SPI, and these are included for the serial interface, and you may use I2C or some other protocol, but I am using SPI. After that, these are the values. This is the threshold value, and it decides where about the line, the black line on which the sensor is running. And these are for the speed. This is for the turn speed, meaning when it turns right or left, and this is for the speed which will be used when it runs in the straight line, and it is for the thickness of line, which is 0.75. You may change it all these values according to your program. And we are using Z units. This is a unit, fictitious unit, which means it is not real, but we have created it for our own simplicity, and it is equal to 17,000 of every inch, like meaning there are 17,042 Z units in 1 inch. It is a very small unit, but we are using it for our own simplicity. You may use Z units if you want to, but it is much simpler to use the units which are given in the sample program. And after that there is overshoot. This is a function, we can read it later and see how it works, but it is for the line thickness into inches into 0 units and multiply with line thickness over speed for the overshoot. And after that there is the push button, which is this one, and this is for the my file. We will be using these later in our program. The thing which we have added beside the simple program is the LCD, and I am using these pins as 0 1 2 3 4 5. You may use other pins according to your program, but since I don't need most of the pins, so I'm using in this fashion, and I'm using it I'm using only 4 pins since I'm using it in 8-bit mode, since there is no use of it a lot. Just we will be representing whether the whether the robot is moving left, right, or straight. These are the pins connected to the microcontroller, and after that this is the I told you the pins about these. You may change them according to your program. And here is our word setup. Let me just do this. These were the changes which I had done in the other program, so it was easier for me to explain the code. Since the code is long, it is sometimes difficult to find different functions which I have to explain. So in the word setup, this is the serial begin, which is used for the interface. After that, LCD begin, since this is the position of the LCD, and SD initialize. This is the function which initializes the SD card. Let me explain it to you, but let me add some Since it is a long code, it is sometimes difficult to find different functions. So this is the function initialize. Basically, it will display the values which are in the beginning of the code. Here you can see that. Pardon my PC, it's a little slow. Don't go there. Hmm, simulation failed, but it was just running. I think card is also inserted and the MMC file is added. It is also here. Yeah, it's working now. So let's you guys just need to look at the LCD. We don't need that. We will just look at the LCD. What happens when I run the program? You can see initializing SD card. This is the first function which happens, and after it is initialized, the robot will just stay in the position. All of that is right here in this function. Initializing, and then it is just moving the LCD cursor. You can check my previous videos for a detailed version, but all of this is just to move the cursor from this position to this position, so it is displayed in a better manner. So initializing SD card, and it will LCD clear and chip select to see the SD card is inserted. After that it will again initialize, done initializing, and it will add, we are using this function, so the SD card is added. And after that it will go back to the loop. See, these are very helpful now. And after it's initialized, we are giving some values to these variables of different data types for sensors and some arrays. And after that it is playing the buzzer, which you would have heard. And after that there are some more functions. This is for the reflectance sensors and motor speed. So I think, yeah, we are still in the main. this happened this happened, and the buzzer. And after that it will just wait for the button, this button, this one Zomo button. Unless it is pressed, the Zomo won't move, and when it is moved, it is pressed, it will start working. So where is the other code? Yeah, this is the loop. So what it does is, first of all, it will solve maze. This is the function which will solve the maze. So let's explain this function. Our loop function is very small. This is all of it, since we are using different functions for all of the things which are being done. So sol maze is the function which we have to explain. Let me look for it. So this is the function, you can see sol maze. This is the function which is called in the loop. First of all, there are some characters: found left, found straight, and found right, and the robot will use them in this manner. Since you can, there are sensors 1 2 3 4 5 and 6 sensors. We will use these values to move the robot left, right, or straight. If the sensor 0 is if the sensor is 0 and found left is 1, and if the sensor 5 is high, found right is 1. And there are some more sensors, sorry, more functions. This is the motor speeds, which will use the speed which we have declared in the beginning, which was 300. You can increase or decrease it, but keeping it moderate is best for us, since it will be very slow if we decrease it a lot, and if we increase it to higher values, the turns won't be smooth, or our sense robot will move in wrong directions. I mean, it will miss the directions. We are using these sensors as we use in a simple line follower. Unless this is high, meaning it will go right. These two are high, still right. These three are high, still right. And if this is high left, this is left. And if these are all are high in the middle, it will go straight. This is the basic logic for it. You can see that we are giving the values to found left and found right, and for the straight, meaning the middle sensors are high. This is the logic for it moving. And in the end it says simplify path, that is the function. Sorry. So simplify path is the function which is called in the previous function, which is the solve maze. So it works pretty simple. Unless the value is positive, it will move left, and if the value is negative, it will move right. This is how it is working here. And for right, left, and straight, there are different angles which according to which the robot will turn. So we are using now, using the values which are saved here, we are using switch statement for the total angle. And if it is -3, it is S, and if it is -3, this is right, and again B and L. So the path is now very shorter as compared to previous one. Let's go back. After that, this is for the saving values, and for my file dot print and my file dot println. And if it doesn't work, it will just say error opening file. Here, let's run it till it works now. It is initialized. Let me just try to make it a little small here. We have explained the pins of LCD, microcontroller, the robot, the SD card. Yes, I haven't explained those. This is MOSI and MISO, Mosi and Misopen. These are usually read as a master out slave in or master in slave out according to the microcontroller or sensor to which is it's added. Here it is slave in, and while here it is master out, here it is slave out, and here it is mastered in. You can check my previous video for SPI if you want to learn it in detail. These are the pins used here in the microcontroller, and these are for the virtual terminal. Let's just see if it is working. So I have first I am using this reset button. This is the reset button on every microcontroller. So when I reset it, the program runs from the beginning. So it will initialize the SD card. Initializing SD card and done initializing. It's a little noisy. So it will just stay right there. Unless I press this button of Zumo, it won't move. And when I press the button, first of all our Zumo will move left and right for the calibration, which I have explained how it is working in the code. And after that it moves forward, and according to the values, if the value is positive or negative, it will move left or right. Since here the value will be most probably positive, so it will move left, and then here it will go left and right, and again it will come back now, since the path, there is no more path here. Likewise, it will reach the end, and at the end all of the sensors are high. So the robot, it is the stop for the robot, the condition. Unless there is no place in which all the sensors are high, the robot won't stop. It won't reach its destination basically. So this is how it's working. So the SD card is initialized. All I have to do is click this button. Wait, it's a little noisy. So it is working. You can check the readings on LCD for straight, left and right. So all the values are being displayed, which will be saved in the SD card. So the robot is now moving right, left, and then again left. So now next will be right, right, and again right. Now left, and it will move straight, again left, and then it shall move right, and now it will go back, and it will stop at the destination. I hope I have covered each and everything from the simulation to code. Let me think once again. So we explained the pins, we explained the working, we explained the logic, we explained the code. But still, if there is something missing, I will make sure to make a video and add it. And if I still don't do it, and there are any questions, you can ask in the comments. I will make sure to answer each and every one of you.